Okay, let's talk about multiplying vectors. Vectors are just either one row or one column matrices. And I'm going to try A times B. A is just a row vector with the elements 1 and 2. B is a row vector, elements 3 and 4. A times B. Doesn't work. Incorrect dimensions. The number of columns in the first does not equal the number of rows in the second. Element-wise multiplication, use dot star. The ordinary multiplication that we're used to, we got to use dot star. MATLAB stands for Matrix Laboratory. It is so it does matrices. It's designed to do matrices. It's not designed to do regular calculations as well. That's why you're looking, why doesn't it just do regular calculations like star, like a regular multiplication sign? Why doesn't it do that? Well, because that's not its purpose, that's not its intent. The intent is to handle this stuff called linear algebra. And it does it quite well. But regular calculations, it's got to do something a little different, and it makes it a little harder to do regular calculations. Remember at the very beginning, I said MATLAB will take you longer than Excel for easy problems, but for hard problems, it does things better. There's kind of a crossover. So when you need MATLAB, you need MATLAB. Excel doesn't do matrices so well. MATLAB does matrices very well. Better than Java, C++, Python, all that stuff. That's why engineers love it, because we deal with matrices a lot in the engineering profession. Calculations involve matrices. Okay. Now, let's do the scalar, the element-wise multiplication, A times B. This just takes 1 times 3, and the answer is 3. 2 times 4, answer is 8. That's all. It's element-wise, element by each individual element. Okay, now let's do something different. If we want to do A, we can use the apostrophe. This apostrophe converts B into a column vector in columns. So now the number of columns in the first, which is going to be A, the number of columns in the first is going to equal the number of rows in the second now. It's not element-wise. It gives you 11. 1 times 3 plus 2 times 4. Remember this over here? This one, 7 times 1 plus 8 times 2 plus 9 times 3 gives you 50. So this is, this one here is a matrix times a column vector. Remember all the rules. Over here, by the way, FYI, I've put a lot of things, of hints. The hints that we've gone through so far, everything we've talked about so far is over here. Okay, let's keep going with this. Let's add another column. Okay, so we've got our matrix that we've seen before, right there. This one right over here. And now I'm going to create another matrix. I'm going to try to do something. It's not going to work. What this is trying to do, I'm trying to say, okay, 7, next row, 8, next row, 9, next column, 10, next row, 11, next row, 12. Here's a way to fix that. I want to show you guys a way to fix that. Just do this. Oops, put the wrong bracket in the wrong place. So this much right here creates a column vector 7, 8, 9, which is what we had before, by the way, 7, 8, 9. This creates a column vector 10, 11, 12. And when I put the square bracket around the 10, 11, and 12, it creates that column vector. And it says put these two column vectors side by side. That's what this notation is telling us. You can nest the square brackets, in other words. Okay, there. So now we've got this. Let's go A, matrix multiply B, and we have the answer. The first column is the answer we had before, right here. The second column is as if 10, 11, and 12 were B. Let's try that. C equals the 10, 11, 12. Let's just make C equal to that. Okay. And now A times C. We get this is the answer. It's the second column. C is the second column in B right here. C is the second column. C is this second column. It's like you're taking this vector and multiplying it by A, just like these rules right here. Taking that second vector, multiplying it by A. And putting the answer in the second column. This is in the second column, the answer to this times 10, 11, 12 is in the second column of the answer. So that explains how matrix multiplication works. That should help you out a lot with matrix multiplication. So we've got that part down. Division. What division is, it solves an equation. If we know A and B, and we're trying to find X, we want to solve this equation. Let's go through the process. A goes into A times X equals A goes into B. We're just dividing A into both sides of the equation. A into A gives you the identity matrix. I'll get to that in just a second. But the identity matrix times any other matrix gives you the matrix itself, X. I times X equals X. And of course, the left side of the equation has been, or the right side of the equation is the same. So this expression right here, X equals A goes into B, it solves this equation. That's what the meaning of matrix division is. And it's not the same as right division. I'll show you in MATLAB in just a second that if I tried right division or even B right division A, it won't work. So let's go back. Okay. So we have, we should have an answer. Let's put X, or yeah, let's go A, not A, my A. Okay, my answer equals answer. This variable A and S is just going to get overwritten all the time. So we've already multiplied A times B equals the answer, or excuse me, A times C equals the answer. Let's make A times B equal the answer. A times B. We're going to do my answer equals, there we go. So now we have this. We already know the solution. The solution's got to be, where is B? Solution's got to be B. There we go. There's A. Here's A. Here's B. And here's the answer to A times B. So let's try taking A goes into, and it comes up with a solution. This this shouldn't be a unique solution. Let's see. Let's make a matrix D equals the answer. And I'm going to go A times D, or yeah, A times D should give me 50, 68, 122, and so forth. A times D. And it does. A times B gives us this. So does A times D. More than one answer. That's the key here. That's the key here. More than one answer. I'm going to stop it here. We'll just do a few more. But these are gotchas. This is a gotcha to watch out for.